this is my favorite tradition, conference selfie. Obviously, this sucks because we can't do conference selfie. No, just kidding. I did already conference selfie. I'll just do another conference selfie, very meta. Oh boy, so cool. Okay, thanks for thanks for bearing. Cool. So my name's Andrea. That's my handle on the internet. This is what I look like. Since you can't see me fully, I might look like this sometimes because it's, you know, I might wear pants or not, who knows, because it's remote conferences. So I work at a company called community.com, which is a company that does some messaging stuff. We are hiring very heavily, so please feel free to reach out on to me on Twitter and or email. We're hiring for a bunch of roles, back and front end, and we're hiring remotely. The company is all remote, which is not very braggy to say now because everybody's remote, but we also are remote. This is our website, Text at the Scale of Social. It's a very cool website. Essentially, you can text celebrities and they text you back. This is one of our biggest client, probably. Maybe a bunch of people know who he is. Maybe a bunch of people saw that he posted a phone number. So that's us, very cool. But enough of the company. Let's talk about Mint. So Mint's an HTTP client for Elixir. It's a pretty different client than what was available when we wrote it, both in Erlang and Elixir. I built it together with Eric from the Elixir core team, Eric MJ. So we built it now a couple of years ago, maybe. This is what we're going to talk about today, which is the story and the features of Mint. And we're going to talk about the use cases and for it and the challenges that we faced when writing it. And then we're going to talk about the future plans. So what we have in store for Mint. Cool, so let's start with the story. Why did we write this client, given that it's not the easiest thing in the world? So Erlang ships with an HTTP client called HTTPC, which stands for HTTP client, obviously, and it ships with this client. And there was talk now, maybe 2 years ago, there was some rumors that OTP would be broken out into different packages, and so we thought we would lose HTTPC in the standard library. We're very scared of this because Elixir needs HTTP because we need it for Hex, which is the Elixir package manager, and we use Hex very heavily in the Elixir ecosystem, as you all know. So we need Hex to have an HTTP client, so we need to have it available in some standard library. So we said, okay, they're going to remove it from Erlang. Let's get to work and let's build an HTTP client so that we can use it from maybe our standard library. And we decided to initially to build it in Elixir standard library, to have it in there. So this kind of shaped the requirements. We decided it needs to be low-level client so that we, being in the standard library, we want to have the bare minimum so that it works. It needs to have HTTP 1.1 support, which is what X is using. And it needs to be secure because it's going to be used by a bunch of people to do sensitive stuff like pulling dependencies in all sorts of environments. So those were the requirements that we had. And then we said, okay, it's a modern client and the world is moving towards HTTP2. So we decided, okay, let's put HTTP2 there as well so that we have multi-protocol support built in from the beginning and it's not going to bite us back when we need to implement it or when HTTP3 becomes a reality, for example. So that was the kind of the initial reasoning for building this client. So it needed to be in the standard library. We didn't have anything at that point. It needed to be very low level. So that's kind of how we built the client. So let's look at the overview of the client and the features that it provides. So the very cool thing is that it's a processless client. So essentially it's a, okay, I lost my notes. I'm back. So it's a processless client, which means that there's no process attached, doesn't impose any process architecture. There's no process attached to a HTTP connection with Mint. And that's different than actually all HTTP clients that we were familiar with at the time. right? So HPC, the built-in one, Hackney or iBrowse, I can't remember the other one. So they're all process-based. Mint instead takes a different approach, which is a processless approach, a kind of a more data structure-oriented approach. So if you're familiar with how GenTCP and SSL works exactly the same way, but how GenTCP and SSL work, they are, a TCP socket it's a port in Erlang, but essentially it's a transparent data structure that you pass around, right? And with Mint, we decided to basically build the HTTP client as a thin wrapper around the GenTCP or SSL socket. And the cool thing about this is that GenTCP and SSL, they take care of the fundamental of the communication layer. So they take care of like communicating through TCP or SSL, for example, or like receiving data, sending data, connections, all that stuff. And Mint is just a thin layer around the socket that adds protocol understanding of the HTTP protocol. So it adds HTTP1 and HTTP2 understanding around a TCP socket or an SSL socket, but it doesn't impose any architecture. It carries all the state as a data structure instead of as in a process. So it's a different approach and a very low level approach that allows us to build very interesting things with it, which is we're going to see during the talk. If you want to start an HTTP connection with Mint, you can use the mint.http.connect function. Takes a scheme and a hostname and a port, and it returns a connection. And this connection is the data structure that I was talking about in this drawing, right? So it's the Mint connection is just a struct in Elixir. As you can see in the last line here, it's just a struct that wraps the TCP socket or the SSL socket inside. Plus it has some state around like parsing of the HTTP, parsing of the HTTP requests and responses and stuff like, especially for HTTP2, like a bunch of the state that needs to be carried. It's not very interesting, but it's in there as well. The connection struct is just a piece of data, no processes involved here, just a wrapper around the TCP or SSL socket. Once I have a connection, I can make an HTTP request. And to do that, I called main.http.request. Until now, it's pretty straightforward. Pass the connection, the method, the path, and headers, and optionally body. And if you notice, there's two interesting things in this particular piece of code. The first one is that we have to rebind. If you see in the first line, we rebind the con variable. That's very important because this is all immutable data. As you know, Elixir only has immutable data. So this is all immutable data. So when I make a request, I'm essentially updating the state of the connection because I'm adding a request to the queue and all that stuff. So I can't modify the connection in place because it's immutable. So I always need to use the latest connection. So all the functions basically in the Mint library, in the Mint API, return a connection as well with the updated state. So I'm essentially modifying an immutable piece of data, right? So I have to pass it around. That's we are all used to that in Elixir, so that should make sense. And the third element of the tuple on the first line, the request ref, that's the thing that's going to identify the request that you just made, and it's going to enable you to understand the response and to connect the response to that request. And to talk more about that, it's important to know that Mint is a completely streaming client. There is no synchronous requests and responses. So when you send a request, sending the request is literally a call to, like, it's encoding the request and then calling TCP send or SSL send. So it's just sending the data on the socket, and then it doesn't do anything else. So you get back a request ref, and this request ref is, it's a reference, it's a unique term, and that's going to allow you to identify the request when the response comes back, which we're going to talk about in a second. So in a single connection, you can have multiple requests in flight at the same time. This is especially, it's both for HTTP1 and HTTP2. If in HTTP1, it's a queue, it's like a line of requests, a queue of requests. In HTTP2, they actually can happen in parallel. We're going to talk about that a little bit more, but you can have multiple requests open at the same time. That's kind of the main point. let's talk about responses. So how do you get responses if all of this is streaming and the requests are completely asynchronous? You just send the request, then you need to get the response. Well, the most natural way to get asynchronous data back when it's available in Elixir is messages, right? So usually what you do is that you get the messages, the actual TCP and SSL messages that the GenTCP and SSL libraries provide, if you're familiar with those. So you get those messages back to the process that created the mean connection. That's called the controlling process of the connection, which is the same name that GenTCP and SSL use for the controlling process of the socket. So you get these TCP and SSL messages back directly to the process, and then you essentially have to. They contain raw data that you wouldn't understand at the HTTP level if you didn't pass them to Mint. So what you do is that, as I said, like Mint is essentially a wrapper around the socket. We can't hijack messages in Erlang and Elixir. That's why we can't do anything, that looks nicer than this. But once you get a TCP or an SSL message, you can give it to Mint, and Mint will do the HTTP layer of understanding, right? So it will parse and understand what the message means based on the HTTP protocol. And so, for example, I receive a message here. We have a guard called isConnection message, and it tells you if the message is it belongs to the connection. So you don't even need to actually look at the shape and see, oh, it's a TCP message or it's an SSL message. You just make sure that it's a message that belongs to your Mint connection, and then you give it to the Mint connection. And if you have other messages, you do something else with it. So you can just essentially, when you receive a message, you can feed it to Mint if it belongs to Mint. As you can see in the second to last line there, mint.http.stream, that's a function that you can call with the message, so that Mint will perform some parsing and will understand what this message means in the context of HTTP, and will, know what to do with it. So this mint.http.stream, that's how you, you get some responses back. So the whole flow is you send a request, you get a request ref, and then the request ref is used, will be contained in the response. So you get responses, it has messages, you parse them, and then you can do something with it. As you can see here, mint.http.stream either returns OK or returns error, but it always returns a list of responses. And the responses look like this. They're just tuples, and they have the first element that tells you what the response is. Second element, that's the request ref that we talked about. So it identifies which request this response is for, and then you have some response specific stuff. So these are the main ones: status, headers, data, done, and error. They're all pretty intuitive. Like status is the HTTP status code, the headers are the headers, the data is like the chunk of actual data that you got back. Done means that the request is finished, and error means that the request is finished with an error. So you will know that the request is finished and all the responses are back once you get done or once you get error. So you can only get one single done and one single error. You can get multiple data responses for a request, for example, but you'll always have one done and one error, or one error, sorry, obviously. Okay, so that's kind of the request response cycle. Maybe we're going to see some more examples, but that's kind of the gist of it. As you saw, it's very low level. You need to implement some sort of like a routing of the responses back to the right requests. So you need to keep some state when you get the responses back in the streaming way. But being solo level, it allows you to pretty easily build synchronous requests on top of Mint, but it also allows you to pretty easily build something more complex where you can react to, on the responses as soon as they come back. You can build streaming on top of Mint, which is already streaming, so you can build some more streaming approaches. So it all works very well. Security, we're pretty happy with this. It was one of the goals, as you remember from one of the first slides, it was one of the goals when we were designing Mint. And Mint is safe by default. That's what we like to say. What safe by default means is that if you make a request, by default, it should behave correctly on the security side. So for example, I like to make the example with this self-signed.bedssl.com. So that's a like an existing domain and everything that has a certificate that is valid, but it's been self-signed by them. So if you try to connect, for example, to this with a browser, that's usually what you get something like this. It's Safari thing, but you get something like this. So this browser behaves correctly and tells you, hey, this certificate is not trusted, right? The existing clients for Erlang and Elixir don't behave great with this. So by default, HTTPC, for example, behaves incorrectly. So as you can see, HTTPC actually returns, if you try to make a request to the self-sign.betassl.com, it will return a OK tuple, which is not the best. It just makes the request basically, and it tells you like if everything was fine, which it wasn't really. And so you can configure the SSL options on HTTPC so that it actually behaves correctly. But by default, it's what we're interested in, like safe by default. It's not safe by default. If you make a request like this, by default it works when it should actually tell you that this is a self-signed certificate. Hackney is better. So Hackney actually does the right thing by default. If you make a request to this URL, it will return an error, TLS alert. That's the right behavior. The problem that Hackney has is that if you pass some or that at least had for a long time, was that if you pass some SSL options, it will not merge those back with the defaults. It will actually override the SSL options completely. So for example, here, I'm just changing the TLS version, which is like a single SSL option. And now all the other options that Hackney provides by default, which are correct options, they are completely overridden by my options that I passed. So that makes it, we're back to being not secure, right? Because I will need to pass the right certificates to the right certificate store and the right SSL options to make it safe whenever I change any option, right? So that because they get overridden. So as you can see in this example, this would return OK200 instead of returning a TLS alert. Mint works by default with this. So if you make a request to this URL, it will return a transport error, which is the TLS alert thing. And if you change SSL options, they're going to be smartly merged back to the default one, so that unless you override some specific options to bring the level of security down, basically then it behaves correctly and you're still secure if you override some options. This is overriding these options is pretty common because they can be related to timeouts, they can be related to a bunch of socket level stuff. So it's not like a very rare thing to do. Mint also ships, it's safe by default and also ships with a default certificate store. So that's I mean, we ship with the default certificate store. It's called CA store. We have it as a library up on Hex. That's a URL if you want to go check it out. So it's enough to add it to your dependencies. If Mint sees it in your dependencies, then it's going to use that one. If it doesn't see it in your dependency, it's going to warn that you have no, unless you configure it explicitly, going to warn that it doesn't warn that it doesn't have, or maybe even error out. I can't remember, but it complains that you don't have a certificate store configured. And we provided the default one so that we trust it, and we just sync it up with the Mozilla one and just publish it on Hex when there's updates to that. So personally, we trust it, and it's open source. It's sitting there in that URL, so you can go check it out if you want to trust it too. All the security stuff that is there, it needs a huge thanks to Bram, which helps us constantly because we are very much noobs when it comes to security, especially compared to him. So really thanks. Lots of help with all this security stuff, with the SSL stuff, and now with TLS 1.3, a bunch of stuff. So let's talk very quickly about proxying. So Mint supports proxying. You can pass a proxy configuration when you establish a connection. We have two kinds of proxies. One is, you call it like a request proxy. Request proxy, essentially you connect to the proxy, and then when you make a request to want to make a request to the final host, you make a request to the proxy, and the proxy makes a request to the host, right? So it's It's kind of called request proxy usually. And then we support tunnel proxying, which is essentially where you connect to, so a request proxy is specific to only HTTP. Tunnel proxies, you connect through HTTP to the proxy, and then you could potentially like exchange any kind of traffic. You just, the proxy forwards the traffic to the host and back. So we support this as well for HTTP. Let's talk a little bit about HTTP2. That's the thing that I like the most about this. So Mint has built-in support for HTTP2. The API is very transparent. We're going to look at that. If you're not familiar with HTTP2, a really quick primer is that the main difference between HTTP1 and HTTP2 is that in HTTP1, you have one TCP connection, and on the TCP connection, you can do one request at a time. So you can only queue requests, and there's like a single queue of requests and a single queue of responses. You can't have things actually happening in parallel. So if you have a slow request, for example, it's going to take a long time, and it's going to block potentially faster requests that are in the queue. In HTTP2, for every TCP connection between client and server, you actually have multiplex streams. So you have the requests happen actually in parallel between the client and the server. So every request has an ID. That's essentially how they implement it. So you don't have a queue anymore, but you have an actual parallel. You're still limited on traffic on the single TCP connection. For example, if you make two requests, a very slow one and a very fast one, the server processes the fast one first. It can send you the response before sending you the response to the slow one, and you're going to be able to process it. So it kind of simulates. It uses TCP. I mean, it takes advantage of TCP multiplexing and simulates parallel requests on top of a single TCP connection. The other very important thing that, very important, maybe it's too much, but the other cool thing that HTTP2 provides is server pushes. And server pushes consists of the server being able to push some data to the client without the client asking. So while in HTTP1, for example, it's customary to keep the TCP connection open and do multiple requests on it. But for a long time, you would just open a connection, make a request, and close the connection. And still now, usually connections are closed after a while. In HTTP2, the idea is that the TCP when I say TCP, I always mean TCP or SSL. But those connections are they are stable. They are long-living, and the server, with the server pushes, the server can push data to the client. So it can simulate giving a response to the client without the client actually asking for it. This is a feature that was originally, I believe, thought for web use cases, where a browser would make a request for a web page, and the server would already start handing out like CSS and JavaScript and assets in general to the client, without the client having to ask for all of them, having to make multiple requests. So we support server pushes. A push promise is essentially another kind of response between like among the status, headers, data, all those ones. We also have push promise, and you get a push promise. That means the server is kind of sent. It's a request, like it looks like a request. It has like headers, for example, and the server is telling you, "Hey, I'm going to send you some. Response to this request that I think you will want to make." So we support this natively as well. Another thing in HTTP2 that's small but cool is that HTTP2 supports pinging and ponging between client and server, and we also support this. So if you can use min.http2.ping, and you will get another kind of response, which is just a pong. And if the server pings the client, we will just under the hood we will reply. There's a bunch of other features that are cool in HTTP2. Back pressure is one of them. So you can, like the flow on the socket is controlled by the actual protocol, and it can be negotiated between server and client. You can cancel requests, because since requests are in parallel, you don't have a queue, so you can actually cancel a request and never get a response. That's totally fine. You have a parallel request. We talk about it. You have settings negotiation, where the client and the server can actually discuss, agree on things like, oh, how many requests can I do in parallel, or how many data I can send, how much data I can send around. And Mint supports all of this stuff, which is good. And the last cool thing is that about HTTP2 is that HTTP2 and HTTP1 and Mint have exactly the same API. So you have a mint.http module that's kind of top level one, and that does the protocol negotiation. So it actually figures out, oh, does this server use HTTP1? Does this server use HTTP2? So it figures it out by itself. If you want to use specifically HTTP1 or HTTP2, you can use the mint.http1 or mint.http2 modules, but the API looks basically identical. There are some differences, some additional functions in HTTP2, like ping, for example, that are not supported in HTTP1, but other than that, the API is exactly the same. So you should mostly not care about this. Feature completeness, right now Mint is feature complete. It has, it supports stuff like stream requests, supports stuff like trailing headers, chunking. It has good error handling, supports protocol negotiation. So we at this point, we're there. We're not planning on adding anything really. And let's talk about some use cases. So the cool thing about Mint is that, again, the connection is just a piece of data. It doesn't impose a process architecture on your in your application, so HTTP client process architecture. So what you can do is you can take your connection, you can shove it in a gen server, for example. If you have a gen server that's already doing something, you can put it in there. You can wrap it in a gen server if you want to have like synchronous requests and keep the state in a gen server. You can shove it in a gen stage. That's totally fine. It's still another like process, so you can just put it in there and it's going to be fine. Historically, that's been horrible to do, because if you have a gen stage and you want to have a connection that's connected to the gen stage process, you would have a process that holds the connection, and the gen stage process refers to this process. So you have one more process that you don't need. And when you have two processes that you don't, like a process that you don't need in the between your HTTP connection and your process, then you're gonna copy data when you send and receive requests, send requests to receive responses needlessly, right? And I can go on. You can shove it in a gen state machine. You can pretty much put it anywhere. Another cool thing is that if you have a process, you can put multiple main connections in it without having to use multiple processes. That's also cool. And another cool thing is that you can pass these connections around between processes, so that instead of passing the data around, you can just pass the connection, and then the process that you have can exchange the data with the socket directly, instead of exchanging the data with a process in the middle, right? So this is actually HTTP client that we're going to talk about later that's built exactly like this, where you need to make a request, there's a pool that holds the connection, and you ask the pool, can you give me the connection struct? The pool checks out the connection to the process does the request, and then it checks the connection back in, all by moving the data structure and not moving the data around, which is very, very efficient, as it turns out. Another use case that I like is gen stage pooling. This is the sort of stuff where you can have HTTP connections in consumers, and you're gonna have producers, for example, making like producing requests as event, if you're familiar with events, if you're familiar with gen stage, and then you have the connection, HTTP connection, right directly in the consumer. You can put it in the producer. So for example, the producer makes the requests and then uses the responses as events for some other producer consumers or consumers down the pipeline. So a lot of use cases that very, very flexible, that don't impose, just given by the fact that we don't impose a process architecture. Some challenges when building Mint. The first one is definitely mutability. It's very, very nice. This is just the connection, it's just a piece of data, but it makes it hard to do some stuff. It makes it a little bit hard to keep all the state, especially stuff like HTTP2, where there's a lot of state to keep around, and it would be nice to be able to react to stuff internally and not having the user to always come in and pass this data or structure around. But so that was definitely challenging. Proxying was challenging, and we are limited right now to having one proxy connection connect to only a single host, while proxying by nature supports having a single proxy connect to multiple hosts. We can represent that with a single connection in Mint. For now, not at the Mint level. You can build something on top of it that simulates it, but not at the Mint level. But this kind of falls back into a principle that I really live by, which is that easy things should be easy, hard things should be possible. So what we want to do with Mint is like make the easy things that you most commonly want to do. Those should be easy to do. The hard things just should be possible, you know, like maybe we don't need to make, for example, for proxying, it should be easy to use a proxy, right? Like the most common use case is to use a proxy. You can use a proxy, but if you want to build like a very efficient single connection that to a proxy that proxies to multiple hosts, then that should just be possible. We should just not get in the way, which is what we do, but we're not providing it with the library. That's so that was a challenge, but I think it's working fine. Future, Mint is done. We are really happy with it. It's very low level, but it's very stable. As in 1.0, actually we are 1.2 at this point, but it's been 1.0 for a while. So it's been working very well. The biggest thing to do basically on top of Mint is to build some pooling around it. And I'm talking about single host pools and multi-host pools. So a single host pool would be a pool of connections to a single host. A multi-host pool would be something like Hackney, where you just have an HTTP client and you make requests and it figures out connection pools to the right hosts and which connections to open, which connections to keep closed. We started working on a single host pool about maybe a year and a half ago. That did not go anywhere, so we don't have time to work on it, so we just dropped it. It was called Mint Pool. It would have been glorious. I had a bunch of slides. Those are all in the trash for now. Not going to build it, so we'll see. We'll see. Luckily, at this point, while we were not working on anything, Finch came out. So Finch is definitely what I would recommend to use if you want to use Mint in a kind of standard use case. So Finch is an HTTP client built originally by Chris Keithley. Now a bunch of people that worked on it. This is their logo. I took the liberty to make it by drawing. But Finch, you start a Finch, it's a multi-host pool. So you start a client by putting it under your supervisor. You can do stuff like, build requests and then make those requests, get a response. It looks pretty straightforward. It's doing a bunch of stuff on top of Mint in the background. It's using Nimble Pool, which is a library built by Jose and Dashbit to do exactly the sort of stuff where you have your check-in and check-out resources from a pool instead of processes. And that makes Finch extremely fast because essentially when you make a request, you get connection to data structure, you make the request directly through the connection and you get the response, which just makes it extremely fast because you're not passing data around between processes and copying it, but you're talking to the socket directly, which happens usually at the operating system level. So the features of Mint Finch is really fast. Based on Nimble Pool, it has multi-host pooling support, it has telemetry support, so it really looks good. I recommend to use it now. That seems like if you have a use case, for example, where you use Hackney, maybe give it a try. It works very similarly. It works pretty well. If you have more complex use cases, then when you can drop down to Mint and use Mint directly to do some strange stuff. Future of Mint, maybe WebSockets. We're not sure. Maybe we'll think about it. gRPC, we could build a gRPC client on top of Mint. That's something that a bunch of people expressed interest in. Maybe we'll do it. HTTP3, I want to just take my eyes out if I think about having to write another protocol. Maybe we'll do it, but I don't think that that's going to be fun. HTTP2 was not fun. Let me tell you that. So I don't see why HTTP3 is greater than 2. So I believe that that's going to be less fun. Some resources, I'm not going to read through those, but I'm just going to leave this slide up. And it had, you'll have this slide when the slides are posted somewhere. And there's just some like a Mint, the article on the ElixirLang blog, Finch link, another article about HTTP clients in Elixir from AppSignal's blog. So that's all. And that's all for me. That was my last slide. So I believe that at this point we have 5 minutes, right, Joe? For Q&A, and I have 3 questions in the queue. I have 3 questions in the Q&A, and I have just a few messages in the chat. I want to address one in the chat because I get asked all the time. This is just the slides are made with an iPad and Apple Pencil and the app paper, and they're very badly drawn, but it works. So that's my strategy. Should I go through the Q&A, Joe? What do you think?
Yeah, sure. I mean, I can only see one question, so maybe something's up with what I'm looking at. So if you want to work through them, okay, I can see 3 of them now. We've been asking people to ask the questions themselves and unmute themselves to ask them. So
that's good. Yeah.
Yeah. So I'll go ahead and ask. I'm sorry, I can't pronounce your name. Maybe it's Webb Martin. We see you on the Elixir forum a lot, I think. Maybe you could unmute yourself and ask your question. Okay, I guess maybe not. Ah, that's not so. That's not so software focused. It's more about your name. So maybe we'll go to the other question, which is
What do you hide? I'll never tell. Would defeat the point of the username.
okay, same person. I guess I'll ask a question then, which is how does Mint, being processless, handle HTTP keep alive connections that are supposed to be kept open?
That's a good question. So Mint doesn't keep anything. It's a wrapper around a TCP socket, and in Erlang, when you open a TCP socket, unless you close it or the process that controls it dies, then it stays open. That's a kind of behavior of TCP in general. So Mint is just a wrapper around the TCP socket. So it sits there, it's open. The connection, the TCP socket that the Mint uses underneath is alive. And unless there's a disconnection or an error happens, or you manually close it, or the controlling process dies, then it's going to be alive.